know how to use the information from a balanced equation to solve problems. In other words, we're able to use it to do stoichiometry. Let's take a look at a more realistic example of where we can apply that information. So in the previous examples, we looked at using the mole-to-mole ratios, which are just the coefficients from the balanced equation. In the lab, for example, when you measure things out, we don't measure out things in number of moles. We usually measure out masses, for example, in grams. So how does that relate to stoichiometry? Well, let's take a look at an example to illustrate that point. So it says here nitrogen monoxide, dinitrogen monoxide, N2O, is used as an anesthetic in dentistry, and it's made by heating ammonium nitrate. And we're provided with this balanced equation. All right, so that's the first thing we have. We have our balanced equation, and then we're asked calculate the mass of ammonium nitrate. So the ammonium nitrate is this thing that must be heated in order to produce 10 grams of nitrous oxide. Right? So the nitrous oxide is this thing, the N2O. Determine the corresponding mass of water produced in the reaction. So let's take a look at the first part of this, part A, and let's organize the information in a way that makes sense. All right, so we're given the balanced equation. And then what we need in this problem is we need to calculate the mass of the ammonium nitrate. So we need the mass of the NH4NO3. And what are we given? Well, we said how we need to find how much of that is needed. It must be heated in order to produce 10 grams of nitrous oxide. So we need the mass of NH4NO3 to produce 10.0 grams of N2O. Okay, so the two things that we're trying to relate in this equation are the two things that we have circled. Okay, so that's the ammonium nitrate and the N2O, right? So in part A, those are the two things that we are trying to relate. And the relationship between them, the only relationship between them that we're provided with, so between the NH4NO3 and the N2O, is from the equation. Okay, and specifically, it's the mole-to-mole ratio, right? And that's what we get from any balanced equation. And in our equation here, it's a 1-to-1 mole ratio, right? When you don't see a coefficient, 1 is understood to be there. So this tells us that 1 mole of NH4NO3, okay, is needed to produce 1 mole of N2O. Okay, that is from the equation. There's nothing special that we need to do. We just read those coefficients. So that's our relationship that connects one thing to the other thing that we're given in part A. So we are also provided with not moles, but we're provided with mass. This is the mass of N2O, and what we need to find eventually is to convert that to the mass of the ammonium nitrate, NH4NO3. So how do we get from mass of one thing to mass of the other? Well, we just said the relationship between those two things is a mole-to-mole relationship. So in order to use that mole-to-mole relationship, guess what? We need to convert the mass of the thing that we're given into moles first, right? So our setup here, our plan is going to be as follows. We're going to convert the mass of the N2O to moles of N2O. And once you get to moles, then we can use our relationship, our mole-to-mole relationship from the balanced equation that will allow us now to convert it to moles of the thing that we want, the NH4NO3. And then once we get to moles of the NH4NO3, then we can convert that to the mass of the NH4 ammonium nitrate. Okay. And going from mass to moles is something that you already know how to do. So we'll put in what these relationships are that we can use here. So to get from the mass of N2O to the moles of N2O, we're going to use the molar mass of N2O. Okay, to get from the moles of N2O to the moles of NH4NO3, okay, this is what we're using, our mole to mole ratio, and that's the central part to any stoichiometry problem is that mole to mole ratio. Okay, and then once we get to moles of NH4, NO3, then we can convert that to the mass. And again, moles to mass or mass to moles, we're going to use the molar mass of that thing. And in this case, it's the molar mass of ammonium nitrate, NH4NO3. Okay, so we've broken that down, getting from mass of one thing to mass of the other. We've broken it down into 3 steps. Okay, the first step and the last step are things you already know how to do, right? That's using the molar masses. You can calculate those very easily. The only new thing here that you're learning how to do is to use our mole to mole ratio, which we talked about in the previous video. Okay, so we're incorporating all of these things now into one big calculation. So let's go ahead and we can solve this. Okay, so I'm going to start off with the mass that's given. Always start with what's given. So we have the 10.0 grams of N2O and keep track of your units. So 10.0 grams of N2O, that goes over 1. We're going to use our molar mass of N2O now as our next, or our first conversion factor. And if I want to end up with moles of N2O, that mole of N2O goes on top. What's the molar mass? Well, it's 2 nitrogens and 1 oxygen. Okay, so that would be 44.02 grams of N2O. Okay, so that goes away. And then our mole to mole ratio, which is our next step that we're using here, it is simply a 1-to-1 mole ratio. Okay, so we have 1 mole of the N2O that goes on the bottom because I wanted to cancel. And I want to end up at the end of this step with moles of ammonium nitrate. So that goes on top. Moles of N2O cancels. And then the last step, using the molar mass of ammonium nitrate to convert it to grams. So ammonium nitrate molar mass, we have a nitrogen, 4 H's, another N, and 3 O's. We add all those together, and we get 80.05 grams of NH4NO3. Okay, and that is for every 1 mole of NH4NO3. Moles cancel out. And the only unit now, take a look at my calculation. Okay, the only unit I'm left with is grams of ammonium nitrate. And that is what I needed to find, right? I needed to find the mass of the ammonium nitrate. I can go ahead and use my calculator, evaluate all of this. And then what we should get then would be the 18.2 grams of ammonium nitrate. Okay, and we have 3 sig figs because I think, let's see, we have 4 sig figs in this number. This is a exact relationship. We have 4 sig figs here and 3 sig figs in our original value. So that takes precedence because that's the least number of sig figs. So we round it to 3 significant figures in our answer. So this example here is a much more realistic example of using the balanced equation in stoichiometry, because again, in the laboratory, right, we don't measure out things in moles. We usually measure out in grams or milliliters or something like that. In this case, we can use that mass, convert it to moles, and then use our mole to mole ratio from the balanced equation to connect one thing with any other thing in that equation. So as you are practicing and as you're doing practice problems in your homework and elsewhere, the ultimate goal of stoichiometry, in order for you to use this balanced equation, whatever that equation is, there's one very important thing that you need to do. Okay, and that is to get to moles. Okay, once you get to moles of either the reactant or the product, Then we can use the mole to mole ratio from the equation to connect the moles of that thing to moles of any other thing in that problem or in that equation. So if I wanted to do part B in this problem, I'm going to do something very similar now. So now I'm asked to determine the corresponding mass of water produced in the reaction, right? So now in part B, what I need to do, okay, in part B, so we can write this, I need the mass of the H2O. Okay, so now I'm trying to relate the H2O to the I'm sorry, to the, what were we given here? The nitrous oxide. So we want to relate the H2O to the N2O. Okay, so it's, again, our plan is going to be very similar, except now we're trying to relate two different things. So our plan here is going to be, I'm going to start off with what we're given. Okay, so we have the mass of the N2O. We're going to convert that to moles of N2O. Okay, so getting to moles is key. And that's the same first step that we did in the one above. And now I want to convert that to moles of H2O. And then I can get to the mass of the H2O. Okay, so the same set of steps, very similar set of steps. We're going to use similar relationships. Mass to moles, I'm going to use the molar mass of N2O, which we found previously. To get from moles of N2O to moles of H2O, I'm going to use the ratio, the mole ratio from the balanced equation. And then from moles of H2O to mass of H2O, I'm going to use the molar mass of H2O. Okay, so when I set this up now, it's going to look something like this. So again, I start with what's given. So I have my 10.0 grams of N2O. My first step is to convert it to moles. This is the same step we did above, because here we converted it to moles of N2O. So it's the same step. So for every 1 mole of N2O, we have 2 nitrogens. That's 28 plus 16. So that's 44.02 grams of N2O. Grams go away. Okay, that's this step here. My next step would be use the mole to mole ratio from the equation. And all I do there is I just read the coefficients, right? So from the equation, the mole to mole ratio, the mole to mole coefficient is 1 mole of N2O to 2 moles of H2O, right? So it's a 1 to 2 mole ratio. So in this case, I have my 1 mole of N2O on the bottom, and now I have my 2 moles of H2O on top, right? And I get this from the equation. There's nothing special I need to do here. Moles of N2O cancel. And then our last step then would be to use the molar mass of H2O, which we can find, okay, 1 mole of water has 1 oxygen, 2 hydrogen, so oxygen 16, hydrogen is 1, so that's 18.02 grams of H2O. Moles go away, and now the only unit I'm left with in my entire setup, grams of N2O go away, moles of N2O go away, moles of H2O go away. Only unit I'm left with is grams of water, and that's what I needed to find, right? I need the mass, the H2O. Use your calculator, and then what we'll find is that equals to 8.18 grams of H2O that's produced. Okay, so similar types of steps. Okay, we need to get to moles first. Then we can use the mole to mole ratio. And then if we need to, we can convert the moles of whatever it is that we found back to grams by using the molar mass of that thing.